The goal of this project is to create an intelligent system that reads a PDF document, cleans and understands its content, summarizes the key ideas, and answers user questions directly from the document text. This project focuses on clarity, reliability, and real-world usability. Instead of complex frameworks, we rely on simple, transparent steps so learners can clearly understand how document intelligence systems work from start to finish. Let's look at the problem statement. Professionals often work with large numbers of PDF documents, such as reports, policies, research papers, and manuals. Manually reading these documents to extract insights or answer questions is time-consuming and inefficient. The challenge is to build a system that reads PDF documents automatically, understands their content, summarizes important information, and answers user questions accurately using only the document text. This mini project solves the problem by turning a static PDF into an interactive knowledge source. So we are building a system that answers questions like, what is this document about? What are the key ideas? How does the document define a specific concept? All answers are grounded in the PDF content. No external knowledge is injected. The key objective includes, first, PDF text extraction. This ensures the system works on real business and academic PDFs. Next, text cleaning and normalization. Clean input improves summarization and question answering quality. Then, semantic representation using embeddings. This step allows semantic understanding beyond keyword matching. Then, document summarization. This enables quick understanding of long documents. Then, question answering over PDF content. This transforms static documents into interactive knowledge systems. Finally, evaluation and logging captures answers, confidence scores, and quality labels. Let's begin with the coding part. First, we have installed the required libraries for our project. These libraries will help us with PDF parsing, text processing, semantic search, summarization, and question answering. Let's discuss one by one. PyMe PDF for reading PDFs. Then Sens Transformers is for generating embeddings. Then Transformers is for summarization and question answering models. And FAISS SCP is for performing fast similarity searches. Next is importing required libraries. Now that the dependencies are installed, we need to import the required libraries to work with PDFs, embeddings, and models for summarization and question answering. Here, RED is the regular expression module used for cleaning the text. Then FAISS is used for creating the similarity search index for embeddings. NumPy is used for handling array operations. Then sentence transformers for creating sentence embeddings. The pipeline from transformers is used for performing summarization and question answering with pre-trained models. With these libraries in place, we'll move on to loading and extracting the content from our PDF file. Next, we'll load the PDF file containing our content on sustainable development and extract its text. Here, we first set the path to the PDF document. Next is the load PDF function, which opens the PDF file and reads the text content from each page. It uses Fitz's open_PDF_path to load the PDF. Then, for each page, the page.get_text function is used to extract the text. The function returns the extracted text from all pages as a single string. For this demonstration, I used a small PDF with limited text. The goal of using this small PDF is to show how the extraction and cleaning process works. When you're working on your own project, it's important to use larger PDFs with more content, like reports, manuals, or academic papers. Larger PDFs provide richer content, which leads to better model accuracy and more insightful responses during summarization and question answering. Now that we've extracted the text, it's time to clean and normalize it. Next, we cleaned the extracted text by removing unnecessary white space and formatting issues. So here, the clean text function removes extra spaces and formats the text. Here, this resub function is used to substitute parts of a string. We're using this pattern, which matches one or more white space characters. These matched white spaces are then replaced with a single space in the text string. Then, the strip method removes any leading and trailing spaces from the text, making sure there aren't any unnecessary spaces at the beginning or end of the string. We print the first 300 characters of the cleaned text to verify the cleaning process and its total length. After applying the resub and strip methods, we clean the raw text, removing extra spaces and making sure the text is properly formatted. We print the first 300 characters of the cleaned text to verify that the cleaning process has worked correctly. We also print the total length of the clean text to confirm that it has been processed as expected. So in the output, you can see that we print a preview of the cleaned text along with its total length. The text is now ready for semantic representation. Next, before proceeding with generating embeddings, we checked if a specific keyword like sustainable development exists in the text. Here, the search in text function searches for the keyword in a case-sensitive manner and prints whether it's present. Here, we got the output as keyword present equals true, which means that the word is present in the document. In the next step, we created the embeddings for the document. In this step, we will generate embeddings for the cleaned document text. Embeddings are numerical representations of the text, which will be useful for search and summarization. We use sentence transformer to encode the clean text into embeddings. The shape of the generated embeddings is printed to confirm its dimensionality. Next, we created a FAISS index to perform similarity searches over the document embeddings. Here, we set up a FAISS index, which will allow us to efficiently perform similarity searches on the document embeddings. FAISS basically stands for Facebook AI Similarity Search. It is used for fast similarity searches over embeddings. Here, we created an FAISS index with the same dimension as the generated embeddings. Here, phase.indexFlatIP creates an index using the inner product similarity method, and the FAISSindex.add function adds the document embeddings to the FAISS index. Now that the FAISS index is ready, we'll move on to summarizing the document. So for document summarization, we used a pre-trained model to generate a summary of the document. We loaded a pre-trained summarization model, which is BART, using the Hugging Face pipeline. Here, the summarize_document function uses the BART model to generate a summary of the cleaned text. Then max length and min length define the length constraints for the summary. The summary of the document is printed below. So with the summarized document, we're now ready to implement question answering. Here, we've used a pre-trained model for question answering. The model will answer questions based on the content of the document. We load a pre-trained question answering model using the Hugging Face pipeline. Here, the answer_question function takes a question in the context of the document text and uses the model to find the answer. As you can see here, the QA pipeline is used to generate answers to questions. Here, result answer provides the answer, and result score gives the confidence score. We test this function with the question, what is sustainable development? And print the result. So here, we've tested it with a sample question, which is, what is sustainable development? Now that we've implemented the question answering, the next step is to evaluate the confidence of these answers. Now comes the evaluation and logging part of the code. We need to evaluate the confidence level of the answers and log the results. Here, the evaluate answer function checks the confidence score and classifies the answer quality. Here, you can see confidence float. This parameter represents the confidence score of the answer generated by the model. The confidence score typically ranges from 0 to 1. 0 means low confidence and 1 means high confidence, indicating how certain the model is about the correctness of its answers. Here, the log result function shows that the result is logged, including the quality classification based on confidence. The result is logged in the evaluation log for further review. Next, we need to answer multiple questions and log the results. So now we answer multiple questions from the document and log each answer with its confidence score and quality. We loop through a list of questions, get answers, and log them. A list of questions is provided, and the agent answers each question using the answer question function. Each question's answer, confidence, and quality are printed and logged for further review. The confidence score shows how strongly the model supports the extracted answers. This output shows the model extracted a concise definition of sustainable development from the document, while the log confidence score indicates the answer may be partial and should be reviewed for expansion using additional context. Finally, we save all our results to a JSON file. Then we'll export the evaluation result to a JSON file for future reference. We write the evaluation log to a JSON file named PDF Insights Results.json. A message is printed confirming that the results have been successfully exported. And that's it. You've now built a system that can read, clean, summarize, and answer questions about a PDF document using LangChain and pre-trained models. In this hands-on, we successfully built a PDF Insights Extractor that can read a PDF, clean and understand its content, generate a summary, and answer user questions.
If you enjoyed this video, you can enroll in Great Learning Academy for free. Choose from hundreds of courses across multiple domains and earn a certificate of completion along the way. And if you want to take it a step further, you can try Great Learning Academy Pro Plus with a free trial. It provides access to additional premium courses with more advanced content from distinguished faculty, along with features like guided projects, a resume builder, and mock interviews to make your learning journey even richer. Link is in the description.